So now that we've sort of cleaned up and isolated some of our input values over here, I do sort of want to just speak to the idea of there being many of the same input values in this particular definition. So what you see is that the U and V subdivisions here are, kind of redundant. There are a lot of them. And also your panelized surfaces have to be used a lot. Now, if that's something that you are okay with and you're comfortable with, that's fine. And in fact, most of my definitions, I don't really take this any further. I'll use these wireless links, and then I'll just kind of take these bigger ideas and group them together like this. And I'll just have a whole string of them throughout my definition. And in some cases, I'll say what it is. I'll say this thing is this, and that way I can read it there. Or I'll put a big panel in here, and that just kind of describes how it works. That's an option that you have at your disposal. But what I wanted to show you is the ability to make a custom component, basically. Oh, can I not go back? All right. This one is kind of our longest definition, and that's fine. It works out well for us. I'm going to get rid of this one that I disabled because I don't expect to go back to it at this point. And what I want to essentially do is take these prepackaged sort of processes, the ones that are going to be done very commonly, and maybe make a custom tool out of it. So that way, any surface that I plug in, right? So any surface I plug in, like this, I can just take a surface, plug it into a tool with a U and a V subdivision, and maybe I could go so far as to do the degrees, but I'm probably not going to do that. But all the way up to the point where I triangulated it here, right? So if I just want to make a predefined component that will take any surface and triangulate it the same way that I did it here using surface 4 point, right? I can do that with a custom component. So in order to do that, though, I'm going to kind of just pull this aside and work on it independently. So in this case, I'm going to take all of this information, right? So the panelized surface, the U and V, all the way up to my two surface 4 points, and I'm going to make a copy of that and move it down. So copy paste, and I'll move it all the way down here. So what's important to know here is that the way that, also go back up here and turn everything else off so that we can see what's going on. You can even turn this old surface off too and turn this on. So what's important to know about these is that essentially the only things that are variable are the number of subdivisions and what surface it's being applied to. Because as you read your way across this definition, right, the list items that you used in order to create your flat or flat edged warped panels, those are going to be a constant. 0, 0, or 0 and 2, they're going to be a constant no matter how you break it down. And then this we probably won't even need, but the list items, right? So these list items, 0, 1, 2, 3, are the 4 points of any quadrilateral surface. So those are constants. They won't change. And so all the way down to the output of surface group A and surface group B, the only part of the definition that's variable is in the beginning. So this tells us that we can input connections on the left and we can output a product on the right, and then break this whole thing down into one group. So in order to do that, there are some tools under params, under utility. There are these functions here, cluster input and cluster output. So what it's called when you group these into one component, it's technically called a cluster. And so when you have a cluster input, let's drop that over here in the beginning. And it looks like this little flag tag, right? It has a name, when you right click it, or sorry, double click it, you can change the name to whatever you need it to be. Okay, so in this case, I can just call it surface. There we go. Sorry, you have to also change the nickname. The nickname is the title. And then you can put a written description in it. So in this case, I'm going to call it surface or brep for triangulation. So then this input gets pulled onto the I, or the S, and the S, I should say, like that. So then the other kind of cluster inputs that you want would be the U subdivision and the V subdivision. So under utility, go to cluster input and let's drop in 2 more. So copy and paste that. And then the first one is going to be U subdivision. And I'm just going to copy and paste that down there. And I'm going to say number of subdivisions in the U direction. And then I'll do the same thing here with V subdivision. Oops. And it'll just say number of subdivisions in the V direction. So now when you hover over it, what you can see is that the title of the node reads U subdivision. The name of the node here reads U subdivision. And then the description down here says number of subdivisions in the U direction. So basically what you're doing is you're building a tool. You're building a component. And so these are going to plug into the U and the V. And then what we're tasked with is moving over to the output side and defining what our output value is going to be. You can delete these now. You don't need these right now. So we trace this all the way to the end to our surface output, and then we have the ability to basically just define what our output is going to be. And it will look like this. Under utility, you go to cluster output. And so at this point, all you have to do is just connect all of your output values into this list and just name it what you want it to be on the output end. So I'll double click this and I'll say I'll call them panel group A. And I'll call this triangulated panels in group A. And I'll plug this one in here. And then I'll make a copy. And I'll revise this one to just be group B. All right, so to recap that, all I did was go to utility, and I pulled my cluster input values over to this side and modified them to read the way that I want them to read in my custom tool. And then on the right-hand side, I pulled in my cluster output values, and I modified those to read like I would want them to read on my output side of my tool, or my component. So I do want to pause and capture the rest of this in one video, but are there any questions at the moment? Okay, so I'm going to pause, you guys get caught up, and then we'll go forward with this. So So with my input values on the left, my output values on the right, I can look through and see that I don't have any other unknowns that should be connected on either end. This is a complete idea, right? All it does is it takes a surface, takes my U and V subdivisions, and then breaks it out into the panel groups that you see on the right. So in order to make it a component, just select everything like this and go to right here, cluster. I forget where it is in the menus. Where is it in the menus? Edit. Yeah, sorry. So you can either just use your hotkey menu here, and you can use cluster, or you can go to the edit menu and go to cluster right here. It's up to you, but when you click on cluster, what it does is it takes that entire thing and it just breaks it all the way down into one panel. Super cool, right? So now, check this out. All of that stuff that we did up in the top, basically this entire part of this definition, if I move this next to my input values, all I have to do is take one of these surfaces, so I take my panelized surface and I plug it in. You can see that it automatically broke it down into a triangulated surface. Of course, it's using default values for everything. So if I take my number of subdivisions in the U direction, my number of subdivisions in the V direction, I have a fully functioning panelized surface with a custom tool. Pretty cool, right? I think it's pretty cool. So, what are we going to do with this? Right now, this particular tool is, we may or may not visit triangulation a lot in the future, but I want you to be aware that you can do this. Because once we start to move into analysis tools and stuff like that, you'll be able to create your own tools that you can just use and repackage and just kind of like load and unload the way that you would want to use it personally. So the other thing that I wanted to show you is that these particular items, once you've defined them, also look, if you hover over it, it shows you the actual inside of the definition right there. It's kind of neat. I like that. But so anyway, you can save this and load it into your toolbar above. And so you'll have, right now we don't have it, but it'll eventually have another one of these that's called user. So if you think about it, all of these other toolbars are basically, whether or not you've gone through and just programmed it using, regular computer programming, or if you did it this way using visual programming, you're building your own tools, which is awesome. So we're going to have another one called user. And in order to do that, you have to go to File and Create User Object. So this allows you to take that cluster and rename it into something, however you want to name it in order to use it in the future. So I'll call this one Triangulation Panels. And I'll just copy and paste that same name. And I'll say this one splits a surface into two groups of complementary triangulated panels. And then you can change the category that it goes in. Essentially, you have the ability to override and put this tool in whatever one of these toolbars you would like it to go in. Do you have to do that? No. User is generally a pretty good way of differentiating your custom tools from the ones that are prepackaged with Grasshopper. So you could also limit it to like a drop-down panel or something like that if you wanted. But if you don't limit it to the drop-down, it'll show up at the top. So the other thing you can do here is change which panel section it goes in. So notice how this has a 0, 1, 2, 3. That's what the panel section is going to do. And then you can also use an icon. Like you can load your own icon if you want, which is a lot of fun if you wanted to make your own icon. But generally, the current icon image is just this little prepackaged box. And if you don't override it, I don't think we have any. We don't have any icons to load right now. But if you don't override it, when you hit OK, this user panel pops up. And so now you've got this tool right here that's called Triangulation Panels, and it says that it splits a surface into two groups of complementary triangulated panels. And when I click that and I drop it in, that's what it looks like. How awesome is that? I'm going to start bringing Red Bulls in the class for you guys. Just saying. All right, anyway, so I don't think you quite understand how awesome this is yet, but as you start to develop your own workflows, your own processes, you'll see that this is like an extremely awesome feature. So anyway, if there are no questions, we'll move back into the actual development of this definition, where we're going to start to go over fritted glass patterns and a couple of more ways of doing more dynamic patterning on this kind of facade. Oh, okay.